Good morning, friends. Today we're going to do our last conic section that we need to cover, which is parabolas. So you've seen parabolas starting since Algebra 1 and Algebra 2, but you're used to seeing the equation in standard form. For today, we're going to be looking at our equations in a different form than what you're used to. So just like the other sections, there's two different equations depending on which direction that your parabola opens. So if it is a horizontal parabola, meaning that it opens either to the right or to the left, this is your equation here. If it's vertical, so that means that it's either going to point up or it's going to point down, this is your equation here. And we'll talk about all the parts in a second. One thing to be aware of, so horizontal means left or right, but it has to be one or the other. So the way you can tell is if P is greater than 0, so numbers greater than 0, it just means positive numbers. Then that parabola is going to open to the right. So that example that is shown, that is a positive parabola. If it is negative, so P value is this number here. If that is negative, then it's going to open to the left. And same thing for the vertical. So the two directions we have for vertical are up and down. If P is positive, then it's going to open up. And if it's negative, it's going to open down. So when I say P, I am referring to this value that's here. Okay, so let's go through all the parts of the parabola that we need to know. So the easiest part of the parabola that you're always going to be able to find is the vertex. So all the other conic sections, the circle, ellipse, hyperbola, they had a center. But for parabolas, they have a vertex. And that's going to be located at HK. So looking at our examples up here, vertex for both of these is right in the center of the graph. Okay. Another thing that should sound familiar to you guys is the axis of symmetry. The axis of symmetry is the line that divides your parabola into two equal halves. So that's not something that you're really going to see on the graph, but it'll help you when you're trying to draw it later. So when it's a horizontal parabola, your axis of symmetry is going to be a horizontal line. When it's a vertical parabola, your axis of symmetry will be a vertical line. And see how here's our parabola and it just gets cut in half. Parabola and cut in half. That's exactly what the axis of symmetry is supposed to do. So I'm going to label this AOS just so we can remember that it means axis of symmetry. Okay, next part is the focus. So the focus is a point that always lies inside of the parabola. So think of the parabola as a cup. So the cup shape, see how it's kind of pointing that way? So your focus has to be inside of that. So that's going to be this point right here, that kind of random dot that's in the middle. Same thing for vertical. That is the focus. So this one I do want to label. And focus. Okay, the other thing, the other kind of random dotted line that's just out there, that is called the directrix. And that line is always going to lie outside of the parabola. So if you look at those pictures here, that dotted line, that is the directrix. So it's always going to be perpendicular to your axis of symmetry. It also goes a different direction. So like if your parabola is horizontal, your directrix is going to be vertical. If your parabola is vertical, your directrix is going to be horizontal. So a reminder for vertical lines, your equation is always going to be x equals a number. So over here, it'll be x equals whatever number they decide. For horizontal, it'll be y equals a number. Okay, so those are the parts that you need to know. But the other two things that are labeled here are things like how to find. So the vertex is blank units away. So looking at your equations here, I know that H and K go where the vertex is supposed to be, so we can't use those. The only other letter that's in our equation is P. So that actually tells you how many units away your focus and directrix need to be away from your vertex. So whatever that number is, it doesn't matter whether it's positive or negative, you're going to go P units away from the vertex. So what we're going to do is say absolute value. Oh, not two, just one. Absolute value of P from the focus and directrix. So what that means is when you're looking at your picture here, I'm going to zoom in. This was our vertex right in the middle. So that means that when I go P to the left, I'll hit the directrix. When I go P to the right, I would hit that focus. So both of these little distances here are P. That's P. And that's P. And same thing if it were to be vertical. It's just going the other direction. So from the vertex, if I go P units down, that's the directrix. And if I went P units up, that's the focus. Okay, and in the last sentence there's another line called the latus rectum. It's a segment that passes through the focus with endpoints on the parabolic curve, and it has a length of 4p. So again, absolute value of 4p. So what that means is when you look at your equations, both of them have 4p. So whatever number's in front of those parentheses, that is how long that latus rectum has to be. And latus rectum, so it's not on your picture, we're going to draw it in. It goes through the focus and lands on top of the parabolic curve. So kind of like that. Let me use, not a highlighter, let me use a pencil. So this right here, that is the latus rectum. So what that does is it tells us, let's do this. It tells us how wide this parabola has to open. It could open, like, it could have opened super skinny like this. It could have opened even wider. But that latus rectum tells us exactly how wide to open the parabola. And that's always going to be 4p units long. So I need it to stay even. So that means that from the focus to the curve, that'll be 2p. And it's going to be over here. From the focus to the curve, that's 2p. And altogether, that makes 4. Okay, same thing for the other one. I'm just going to label that one fast. So a line that touches the curve but goes through the focus. So this part is 2p. And this part is also 2p. And that's the latus rectum. Altogether 4p. Okay, so those are all the things we need to graph our parabolas here. So that's what we're going to do today. We're going to do some examples of graphing. So these are the steps that I would follow when you're graphing. Make sure that it's written in standard form. So make sure that it's written and it looks like this. And determine the type of parabola, whether it's horizontal or vertical. So with this one, it's a little opposite of what you think. Horizontal has y first. So opposite. Vertical has x first. Graph the vertex, which is HK. Solve for P, that way you know which direction that it's going to open. Is it going to go open to the left or right, up or down? Take that absolute value of P to graph the focus and directrix. For P to do the latus rectum, and then you can sketch from there. Okay, so turn to the back of your page. We're going to do our examples. Example 1, we have x minus 4 squared equals 4 parentheses y plus 3 squared. So first thing we want to do is decide, is this a vertical or a horizontal parabola? So like I said, it's kind of opposite of what you would think. It starts with an x, so that makes it vertical. Vertical. So if it's vertical, either it's going to open up or it's going to open down. Like it has to be one or the other, so you have to pick. The way you decide is by looking at this number right here. So whatever is not in the parentheses, that is a positive 4. So when it's positive, it opens up. Okay, so, I mean, we're going to draw it eventually on our graph here, but no matter what, it should end up something like that, like a smile. Okay, next thing we want to do is identify the vertex. So vertex, you get it from the equation from here. H comma K. H is always with X. So this is H and this is K. So when we put that together, oops, I wrote center. This should have said vertex. Okay, so when we put that together, it's going to be positive 4, negative 3. So I'm going to go ahead and graph that on my graph here. 4, negative 3, right here. Okay, so that's the vertex. Okay, next I want to find the focus. But in order to find focus, I need to solve for P. Now remember what's right here, that 4, that is actually, I'm going to go back to our equation. That is actually 4P. So whatever is outside of the parentheses, that is 4P. So for us, we have that 4P equals 4. So if I wanted to solve for just regular P, I would divide both sides by 4, and that gives me that P equals 1. Okay, so what that means for us is that our focus is going to be 1 away from this vertex here. We know that it's vertical and that it's going up, so our focus needs to go 1 up. Okay, so that's our focus. It ended up landing at 4, negative 2. What that also means is that the directrix is going to go the opposite direction. So instead of going up, we're going to go down, and that's where the directrix needs to be, but it's not a point, it's a line. So it needs to be going through about right there. And so that is negative 4, but it's an equation. Since it's horizontal, that is y equals negative 4. Okay, almost done. The other thing we need is the endpoints of the latus rectum. lattice rectum, I'm going to go back to my picture here, is this yellow line that I drew in to tell us how wide that this parabola is going to be. The thing is, once you know what P is, you're going to go 2P up and 2P down, or in this case, 2P to the left and 2P to the right, because we have a vertical parabola this time around. So we need to know what 2P is. So if regular P is 1, then 2P would equal 2, right? It doesn't really take much work to figure that one out. Or we should do this. 2P equals 2 times 1, which equals 2. So I'm going to put LR. For lattice rectum, we're going to move 2 away from the focus. So focus was this blue one. So we're going to move 2 to the left and 2 to the right. Just like that. And I'm actually going to draw the line in. That's how wide our parabola needs to be. So those endpoints are 2, -2, and 6, -2. And then just notice that altogether it made 4. Okay, now we are ready to draw our parabola in. So it needs to open up. We already had that kind of sketch here. This is our vertex, and it needs to go through the endpoints of that lattice rectum. So it needs to go something like that when you draw it in. Okay, so one side of our graph was bigger than the other, so that's why it looks kind of lopsided, but I promise that's kind of close enough. Actually, I'm going to do that a little bit better. I think it's more like that. Okay, and that's our parabola. Let's try the next one. So when you look at example 2, first thing you want to do is decide what direction it's going to open in. So this time Y is first. So this makes that one a horizontal parabola. Horizontal. And then not only that, if it's horizontal, either it's going to open left or it's going to open right. We need to say which direction. So you look at what's not in parentheses. So for us, it's -16. So the fact that it's negative means that it's going to open to the left. So after we get all our numbers and points and everything, it should end up looking like a parabola that's pointing that direction. Okay, so let's start by finding our vertex. Vertex is always the numbers that are inside of the parentheses, but be super, super careful here because it's HK when you're trying to find your vertex. H is always with your X value. So this one is H and this one is K. So if we put that together, again, I put center, this should say vertex. It's going to be at 5, 1. So let's go ahead and graph that. 5, 1. So right here. Okay, so to find our focus, we need to know what P is. So in our equation, whatever's in front of the parentheses is 4P. So for us, we have, sorry, wrong one. We have -16. So we have that 4P equals -16. So if I wanted to solve for P, I would divide both sides by 4. And that gives me that P equals -4. Now, when we're graphing our focus and our directrix, we actually take the absolute value, which means that we would just do +4. Okay, we know that this is a horizontal parabola, And we also know that it's opening towards the left. So when I graph the focus point, we need to graph it 4 to the left. So when we count 1, 2, 3, 4, needs to be here. I want to put an F by it just to remember that's the focus. And that's the point 1, 1. Okay, directrix, we need to go for the other direction. So 1, 2, 3, 4, but we're going to draw a line through there. Dotted line. Okay, and that ended up being at 9, but since it's vertical, that means x equals 9. Okay, and I'm going to write a little d right here for directrix. Okay, the latus rectum. So for latus rectum, I need to find 2p, but if I know that regular p is 4, 2p, you would just multiply 4 times 2. That gives me 8. So I'm going to put LR right here for latus rectum. From our focus, we need to move 8 to both directions. But since we know our parabola is going to open something like that, we need to go 8 up and 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. So here. And then the other way, 1, 2, 3, 4, 5, 6, 7, 8. And I'm actually going to kind of connect those dots. Okay, so those endpoints, the one on the top is at 1, 9. And the one on the bottom is at 1, -7. And now we have all we need to graph our parabola. Again, make sure it's pointing to the left. It needs to hit those endpoints, so it's going to be kind of wide when you draw it in. Kind of like that. Okay, and those are our 2 examples of graphing parabolas. That's all that I have for you guys today. Make sure you fill in these notes and keep it in your folder or your notebook. And tomorrow we will talk about writing equations when you are given this information.